Hi. Today we discuss about hydropower energy. Last class I discussed introduction of the non-conventional energy resources and also what is solar cells, how to construction of the solar cells, how to prepare electrical energy from solar cells, and also how to produce thermal energy from sun rays. All the points are discussed last class. Today we discuss about hydropower energy or hydroelectric power or tidal power. Where hydro means water. The movement of water to produce electricity. The movement of water energy is more than air. Where hydro means water, hydropower means hydraulic or water power, is derived from the force of moving water, to produce electricity. Actually, the moving water force is more than air. Air moving have some energy, but more than air, the moving water is very force or it contains very high energy. Its movement to generate energy or electricity. The movement of water to generate electricity or energy. The electricity generated with hydropower is called hydroelectricity. It is a renewable source of energy. That means it is a non-conventional energy source. It is constantly being refilled by the water cycle. It is constantly refill the water in a dam. The dam area to collect the water and store it use agricultural purpose and also production of or generation of electricity. Working. How to work hydraulic power? During rains in monsoon season, from collect the area the water flow to the dam. In the rainy season, to collect water in a dam area. At the dam, the water gets stored. The potential energy of the water increased. The potential energy of water increased. How to increase it? Because due to increase the height of dam. In case high height of dam, to collect more water, to store more water and improve the height of water level or increase the height of water level. It have more potential energy. When the control gates on the outside of the dam, the control gates of the dam are open, then the water move with high kinetic energy. The water is fastly move. The water velocity is very high and also viscosity is very low. Then to create high kinetic energy of water into the penstock. The high kinetic energy of water first passed in a penstock. It is like a small pipe. The penstock another end to connect the turbines. Between the turbines and penstock have one of the nozzle or screen. Open the screen or nozzle. The water from penstock to turbines. The turbines blades are rotated by the force of moving water. The rotation process is called mechanical energy. The mechanical energy present in the turbines, which is connected with the generator to produce electrical energy. The penstock water goes to the turbine house. It drives the blades of the turbine. The turbine is connected to an electricity to produce electricity in a generator, which productions electrical current. This current is supplied to the powerhouse. From powerhouses, it is supplied for the commercial purpose. This is the commercial purpose and also to supply the different types of areas, towns and etc. This is the diagram of hydropower energy. This is the dam. A dam to store the water. Store the water. The penstock is arranged. This is the penstock. This is the penstock. It is generator. This is turbine. This is turbine blades. The electricity is connected to powerhouses, transformers, etc. The stored water placed in a dam where the penstock is open. It is open. When the open penstock input nozzle, the water is forced. The water is forced passed through the penstock to turbines, where the water velocity is very high. That is called the water kinetic energy is very high. The high force of moving water to hit the turbine blades. By the force of water, the turbine blades are rotated. The mechanical work is created in a turbines. The mechanical work is created in a turbines. On the mechanical process, the mechanical energy passed into generators, where the mechanical energy converted into electrical energy. This is the working of hydropower plant. In this working process, the main important is penstock, pipe and moving water have a very high velocity. Based on the dam constructions, different types of dams to produce different voltages, different electrical energy. For example, micro dams to produce 2 megavolts current. Micro dams macro dams. Macro dams to produce 2 megavolts current. Second, mini dams. Mini scale of dams, small dams to produce 100 kilovolts to 2 megavolts. 2 megavolts. Okay. At the same time, the third, micro dams. Micro dams to produce 5 kilovolts to 100 kilovolts. 100 kilovolts. kilovolts. The last is pico dams. Very small dams to produce less than 5 kilovolts. So different sizes, different area dams are available. Based on that area, how much amount of water stored, that depend on the electrical energy. So micro dams, mini dams, macro dams, pico dams, different types of dams are available in the world. At the same time, different types of turbines is also available in a dams, because some hydropower plant to flow of water based on the movement of water, large water moving sometimes, the flow of water, the movement of flow of water, high flow of water, low flow of water. Based on the flow of water, different types of turbines are used in a hydropower power plant. Large water, in case to move the large water, to use of one type of turbines, different types of turbines. Pelton turbines, Francis turbines, propellant turbines. Different types of turbines are used based on the different flow of water, movement of water. So Francis turbines to use high flow of water, propellant turbines to use low flow of water, large water pass in the hydropower plant to use Pelton turbine. That type of different types of movement of water to use different types of turbines. This is the hydropower energy. Next, geothermal energy. Geothermal energy. Geo means, where thermal means heat. Geo means geology, earth crust, ground earth crust. Geology, like a deep earth crust environment. To study the subject is called geology. So geo, like earth crust, is also to produce heat that heat is also to convert into electricity. Geothermal energy is defined as heat from the earth. It is a clean, renewable resources that provides energy around the world. It is considered a renewable energy resources because the heat coming from the inside of the earth. The heat is coming from the inside of the earth. So that's why it is called renewable or non-conventional energy resources. Okay, there is the introduction. So geothermal energy is defined as heat coming from earth. It is clean and renewable resources that to provide or to generate electricity or power or energy. Okay, in the world. It is considered non-renewable energy resources because the heat is coming from earth crust. Okay, it is not limitless. Okay. So geothermal power plant, how to work? Heat arising from the earth initiators or crust due to the presence of magma. Magma means molten rocks. Some rocks are present in the deep earth crust, but in the deep earth crust have a high temperatures. On the high temperatures, the rocks are melted and melt and flow soft to create magma. So magma is nothing but melted rocks. Magma is less density than surrounding rocks. Rocks are high density. Okay, it rises and heated the water contained in rock porous and underground water. The magma is heated water in deep earth crust like a groundwater in the earth crust heated by magma. Okay, the water becomes heat. This is called as geothermal reservoir. The groundwater, the deep earth water heated by magma. Wells are drilled in this geothermal reservoir. There are two strong iron pipe wells are drills in the geothermal reservoir. The steam is released and supplied to a power plant. The steam is released from earth crust through the pipes. It is passed into power plant. The force of steam is used to rotate turbines. The steam is rotated. The turbines is rotated by the steam to produce electrical energy in a generator. So where geothermal energy like a heat converted into mechanical energy, then after the mechanical energy is converted into electrical energy. The steam is condensed and injected back into geothermal power plant. After rotate the turbines, the energy loss of steam is again passed into deep earth crust. Okay. For example, this is the geothermal power plant. This is the hot water. This is the magma. And also presence of some rocks, porous rocks. This is the porous rocks. This is all the magma. All as the magma. The magma is passed through the porous rocks. The water is heated by the heat. The water is heated by the temperature, where the temperature is increased by the magma. The magma is passed through the porous rocks. With surface area to contain the porous rock surface area to contains hot water, which hot water is warm by the magma, by the heat. But some area, different types of areas to produce geothermal energy, like electrical energy. Based on the area, geothermal power plants are three types. One is dry steam geothermal energy. Flash geothermal power plant or like energy. Binary geothermal power plant. Three types of power plants based on the presence of the temperature. Three types. Dry steam. Some area, the hot water directly converted into steam on the earth crust, because where temperature is very high, so the hot water, deep earth crust hot water converted into steam. The steam is passed into turbines. The steam is passed into turbines. The turbines are rotated on the mechanical process. The generator is taken the mechanical energy and to create electrical energy. This is the mechanical energy. This is the heat energy. This is the first dry steam process. Flash geothermal energy. In this plant, the hot water cannot convert into dry steam. Cannot convert into dry steam. The hot water have a high pressure. High pressure. Have a high pressure. High pressure hot water first to pass into heat exchanger. Passed into heat exchanger. For example, this is the heat exchanger where the steam and water droplets are separated, because where high pressure water to divide into steam and water. The wastewater is passed into cooling unit, and the steam is passed into turbines to produce electrical energy. This is the flash geothermal power plant. Another is binary geothermal power plant. In this area, the water have a low pressure. Low pressure. Where the low pressure water, hot water, first passed into heat exchanger, passed into heat exchanger or evaporated. Heat exchanger or evaporated, where low boiling point liquid also available, like ethane, methane, like ethane, methane or ammonia. Low boiling point liquids is available in evaporator. The low pressure hot water passed into evaporator, where the liquid state of ethane or methane or ammonia to convert it into vapor state by the low pressure hot water. The converted vapors of ethane or methane passed into turbines to rotate the turbine, and the mechanical energy passed into generator to create electrical energy. Okay, after rotation of turbines, the loss of energy, secondary fluid passed into same evaporator. It is the cycle process in binary geothermal power plant, where you use second fluid. But the first and the second process, the hot water, high pressure, or directly the dry steam pass into turbines. Okay, turbines are rotated. Okay, the loss of energy is steam passed into cooling chamber, where the steam is to convert into same water. The water is injects the well into deep water again. This is the geothermal power plant.